Hello everybody, it's me again, and we are on lesson 3 of logarithmic functions unit. Today we're talking about power law of logarithms and change of base rule. We touched upon the change of base rule a little bit in lesson 2, but we're gonna come back to it again later in the lesson today. So, power law. The logarithm of the power of a number is equal to the exponent multiplied by the log of the number. So let's look over here. Log of b of x to the power of n equals n times log of b of x. So what you can do with the exponent is you can just move it over to the front and keep it in the front. It'll make it easier for you to solve. Base has to be greater than 0 and cannot equal 1. X has to be greater than 0. Okay, the proof is right here. Let's say that log a of x equals m. Then x equals a to the power of m, because m is the exponent, remember. So a to the power of m equals x. Now we can say that a to the power of m to the power of n equals x to the power of m. We basically did the same thing to the equation, to both parts of the equation. We raised both parts of the equation to the power of n. When we do bracket raised to the exponent, we multiply the exponent. So a to the power of mn equals x to the power of n. Now, a and x, we can, and to the power of n and m, we can show it in terms of log. N, m here, which is the exponent, equals log of base a of x to the power of n. So that was my base, that was my exponent, and that was my answer. Right? Now I have my exponent equals log of base of the answer. I substituted my log a of x with m. Now I'm going to substitute it back. So n times log ax equals log axn. Now what I do is I'll just bring this log n to the front, and that's what happened here, right? So this equals that. N log ax equals log ax to the power of n. Alright, let's look at some real life examples, basically when we're going to be using it in terms of numbers. Okay, so log 2 of 32 to the power of 1/3. I want to find the exponent that 2 was raised to get 32 to the power of 1/3. I can do it this way. Log of 2 to the power of 5, which is 32, to the power of 1/3. I'm going to simplify it, multiply the exponents, and I'm going to get log of 2 to the power of 5/3, which will just give me 5/3, which is the answer that I was looking for. The exponent that the base was raised to get this answer right here. The other option is to use the power law. What we could do is 1/3 is just bring it over to the front, just like we did here. So 1/3 goes over here, and then we solve the log. Log 2 of 32 is going to give me 5. And then multiply 5 by 1/3, and that's going to be 5/3. Alright, let's look at log of 0.001 to the power of 2. Remember I told you before that when you work with decimals, try to turn them into a fraction. It makes your life easier very often. 2 goes from here to the front of the log. 2 log 0.001 turns into 2 log 1,000, 1/1000, right? If there is no base right here, if it doesn't say what base it is, you can assume that the base is, that's right, it's base 10. So whenever you don't have base right here, it's base 10. 2 log 10 to the power of -3. this is what will give me 1 over 1000, 10 to the power of negative 3. My exponent is negative 3. So the answer to this expression, which exponent will give me 0.001 to the power of 2, when I raise 10 to that exponent, is going to be negative 6. So 2 times negative 3, it's negative 6. So 10 to the power of negative 6 equals 0.001 to the power of 2. The power law can also be used to evaluate logs with bases that are not 10. Okay, always when you work with exponents, you want to make sure that your base is the same. And sometimes it's really hard, and that's when log comes to help you. So instead of guessing and checking which base is going to give you the same answer, you can just take log of both sides of the equation. So 2 equals 1.05 to the power of x, which x is going to give me 2 when I raise 1.05 to that power. Log 2 equals log 1.05 to the power of x. I take logs of both sides. Then I apply the power law right here. I bring this x over to the front and divide both parts by log of 1.05. So by the log that's with the x. And then x from here equals log 2 over log of 1.05, which is 14.2. So I had to raise my 1.05 to the power of 14.2 to get 2. So this technique can also be applied to any base, to any log with any base. And here is the proof of that. I don't have to go over it with you. You can look at it and just basically have a slight idea of the proof, but you won't be asked to prove it. Alright, to calculate the log with any base, express in terms of common logs using the change of base formula. So log of b of x will be log of x divided by log of b. Remember in the previous lesson when I was telling you how to find log of something on a calculator, to find log with a base that's not 10, you had to divide log of the answer by log of the base. So this is the case. Now this is called the change of base formula or rule. So log of b of x equals log of x over log of b. So if you want to try and do it with the numbers, this is what you're going to get. Log of 2 of 41 is going to be log of 41 divided by log of 2. And then you throw it into the calculator and you get your solution. Alright, so that's it. Nothing fancy, nothing complicated. You just have to pay close attention to details as usual and study. We're doing the homework in class again, and please ask any questions that you come up with. See you soon.